The isosceles triangle theorem. Yeah, that's my mark. Okay, you already have that, right? This is not going to work out. To be an isosceles triangle, you have to have at least two sides that are congruent. At least two sides. So in this, hold on, that's too much. It's too much to digest at one time. So let's just look at the diagram. Here you've got a vertex angle. You've got your legs. The legs are the part that are congruent to each other. You've got the base. Move this over a little bit. Got a vertex angle here. There's a leg, base angle, Sure. What do you need?
Never mind.
Yes.
Okay, just wondering, then it says at least two sides congruent, so wouldn't that mean equilateral triangles would be isosceles triangles?
That's right. An equilateral triangle is also an isosceles triangle because it's got two. It's actually got three, but it's at least got two. Good. So here's our isosceles triangle with all the parts. These are parts that we'll talk about later. And the legs, those are the congruent sides, right? In this diagram, the one in blue, and most of the isosceles triangles you see in life generally are standing up so that the sides that are congruent are on the left and the right. That's not always true, though. I wrote another one up here on the top. Sometimes they're sideways, sometimes they're upside down. Sometimes they can be whichever way they want to be. But the two sides that are congruent those are the legs. Then the base, that's the other one, all right? The third side, the one that's not congruent. If you go from the base all the way to the other side, to the vertex, that's your vertex angle. And then your base angles are, oh my God. All right. So is everybody good? We're about to go to a theorem here. No.
Oh, yeah. Let's go to theorem.
Heckle.
Oh boy. Audience clap. Stop.
Good. Okay. Here's the isosceles triangle theorem. If two sides of a triangle are congruent, right? That's an isosceles triangle. If two sides of a triangle are congruent, then the angles, the base angles, the angles opposite those sides are congruent. That is the isosceles triangle theorem. Yes, you can. No, you can say isos, and then make a little triangle, and then THM.
THM. Like this website, THM. Oh, theorem.
So you got it? An isosceles triangle. Here's my isosceles triangle. The two sides, the left and the right, those are the legs in this case, and they're congruent. So that means that the opposite angles those are the congruent angles. Those base angles are the congruent ones. What's up? Yeah. Right. Well, originally, just the definition of an isosceles triangle is that it's got congruent sides, at least two congruent sides. This theorem is saying that if you've got two congruent sides, then the angles are also congruent. The angles opposite the sides are congruent.
Are we going to do proof based on this theorem, or are we going to prove it again?
Yeah. Corollaries. Hold on. You don't want those all at one time.
Is that the pluralization of corollaries?
It's close enough. Okay. Okay, corollary number one. Corollary number one says that in an equilateral triangle, just like how in an isosceles triangle, the angles opposite the congruent sides are congruent, in an equilateral triangle, since all three sides are congruent, then all three angles opposite those three congruent sides are congruent, are equal. So an equilateral triangle is an equiangular triangle.
Yeah.
This came up before.
Yeah.
We talked about this already. Here's where it comes from. All right, corollary number two. An equilateral triangle, and this came up before too, an equilateral triangle, all of the angles are 60 degrees. Three 60-degree angles. The total has to be 180. 180 has to be divided equally into three parts, so each one is 60 degrees. Yes?
And tell me if you're about to cover this, but can you call equilateral triangles equal angles and equal angle triangles equilateral? Can you you need to actually write that that's the definition, or can you just assume that if they're equal angles, you prove that and they're equilateral?
Got to show it. You got to at least write it in.
Okay.
Like you can't. If you need to use one of those angles or two of those angles, you have to write this angle is congruent to this angle, because.
So if you prove it is equilateral, you can just work on the assumption that it's equal angle. Add all three.
Oh my gosh. Corollary number three. Corollary number three is a great one. So when you're done writing this, write down an isosceles triangle. So everybody needs to write down an isosceles triangle so we can prove this. Yeah.
Simple enough to be apostrophe. Geometry is common sense.
It's corollary. It's from a theorem. So yeah, it's kind of, it makes sense after that theorem. That's what a corollary is. It comes from a theorem. It's derived from a theorem. Okay, so does everybody have their isosceles triangle drawn on their piece of paper? Okay. I need you now to indicate which sides are congruent with little hash marks. Does everybody have that? Okay. Now, from the theorem, from the original isosceles triangle theorem, I need you now to indicate on your triangle which angles are congruent. All right. Good. Now, what I need you to do is draw in a bisector up here at the vertex. On the top, draw in a bisector and go all the way to the bottom. Now what I need you to do is think about what a bisector does. Bisects an angle, right? It's an angle bisector, so it bisects an angle. So now I need you to, on your paper, indicate which two angles are congruent to each other. So this angle and this angle. Now looking at that, does anybody see a quick and easy way that we can prove that these two triangles are congruent? I see two ways actually. What do you see? What do you see? I'm gonna okay, let's go in order. Ready? What do you see? Yes. What do you see?
Angle, side angle.
What do you see? Yes. Anybody. I can't really shout out names. Yes. Okay. That's good, but we need a side in there because there's no angle postulate. Yeah, you got it. What do you think? Well, I think you're all right. Because you could go angle, side, angle, or you could go side, angle, side. Either way. So either way, you've got congruent triangles, and then with those congruent triangles, you've got this triangle congruent to this triangle, which means you've got this side congruent to this side. That gives you the midpoint. And then you've got this angle congruent to this angle. Congruent adjacent angles gives you perpendicular lines. Yes, question number one. You could do either one. I did this because I didn't actually know right away if it was a right angle or not. Well, yeah, we just showed that. We proved it. First we showed that it was congruent to each other, but then knowing that congruent adjacent angles make perpendicular lines. So yeah, we could erase that and put in a right angle thing. Indicator, yes, good. Awesome. Yes. I don't know. It's already 12 minutes. Most of these are around 8 minutes.
Well, you can do some editing. Don't enhance the audio, whatever you do.
Okay. Are there any other questions that have to do with triangles? Isosceles triangles. Oh. Yeah. This part, I need you to take a look at your notes. Look up towards the top. The part where you said that in an isosceles triangle, the angles, if two sides are congruent, then the angles opposite those sides are congruent. Wherever you wrote that, you can also write that the converse is true, because the converse of that is also true. If the angles are congruent, the sides are congruent. Oh my gosh. Are you
Oh, hey there, Black Horse. Black Horse.
Hey, we made it. Here's our homework. Here's our